Alright, this is the second part of 3.7. In this part, I'm going to go over a word problem, and I'm also going to go over the special cases. So in the first part of the video, we talked about less thans are treated like ands. We did both of those. You got a chance to try. And greater thans are ors. I went over both of those, and then again, you had a chance to practice. Now, let's actually see a word problem where these are used. So it says some fire extinguishers contain pressurized water. The water pressure should be 162.5 psi, which is pounds per square inch. But it is acceptable for the pressure to differ from this value by at most 12.5 psi. Write and solve an absolute value inequality to find the range of acceptable pressures. Graph the solutions. Alright, so it says the pressure should be 165 psi. But it can differ by at most 12.5. Write and solve absolute value inequality to find the range, and then we're going to graph our solutions. Okay, now this probably sounds hard, but let me show you how simple this really is. Now we're talking about water pressure, so let's use the variable P. Now what it says is the differ, that's difference. So I'm going to put a subtraction sign here. This number can differ by at most 12.5. So whatever the pressure is at some point, if we subtract it by 162.5, it should be at most or no more than 12.5. So that means I'm going to have less than or equal to 12.5. And I'm going to do an absolute value, so that way in case I get a negative, it'll make it positive. And see how it says range? If you think about it, an and looks like this, right? And an or looks something like this. Just don't worry about the endpoints being solid or not solid. The fact is, an and is connected, or is not. So it makes sense for this to be a less than because it's a range. From one end to the other is a range of values. So here's our inequality. Let's go ahead and solve it. Notice I'm going to use the same methods that I've been using. This is going to turn negative, which means I flip my inequality. Notice this is still subtraction. Okay. So we're going to add over here. Running out of space here. Carry the 1, that's a 5. 6 plus 1 is 7, looks like 175. Over here I'm writing plus, but really because this is negative, I'm actually going to subtract. So for those of you that can't do decimals in your head, I suggest you do it long ways to make sure you're doing it correctly. So 150. So because I'm running out of space, I'm going to put it like right here. So we have P less than or equal to 175. And then we have P greater than or equal to 150. Now, this is a less than, right? So that means P goes in the middle. This inequality goes on either side, just like that. Now, P must be less than or equal to 175. That means that's the upper bound. P must be greater than or equal to 150, so that's the lower bound. So there's that, and then let's do our graph. 150 here, 175 there, and I have closed circles on both ends, just like that. So that's it. Okay, so how did I set this up? In this case, P was my variable because it was talking about pressurized water. It says the amount can differ, so that was subtraction. This is the amount that it should be, so this is our base value. So that goes inside. The amount that it can differ by goes outside. Because they wanted a range, it's less than or equal to, because it says at most. So that means it can equal this or be less than. And then of course it's an absolute value because we know we're going to have positives and negative values. We want to make sure we get the positive value. Okay? Alright, now it's your turn. Go ahead and pause the video. Alright, now that you've had a chance, let's do it. See how you did. A dry chemical fire extinguisher should be pressurized to 125 psi, but it's acceptable for the pressure to differ by at most 75 psi. Write and solve the absolute value inequality to give the range of possible or the acceptable pressures, and then graph. Alright, so again, we're going to use P because we're talking about pressurized, looks like a dry chemical fire extinguisher, so usually that's like a powder or something in there that's pressurized. So, P's in the middle. Pressure to differ, so minus. The base, or the main pressure, should be 125, so that goes inside. There's our absolute value, because the total is right in absolute value inequality. Range, less than or equal to, because it says at most, and then this is the most it can differ by, so put 75 there. So there's your absolute value inequality. Hopefully you got that set up. So now let's solve it. Here's the positive, negative. Notice I flipped my inequality. This is 200, so I get P less than or equal to 200. Now be careful, this is subtraction. Okay, and for those of you that can't do subtraction in your head, please take the long way and do it. I'd rather you get it right than wrong because you were being lazy and you didn't want to do that. Okay, now this is a less than, so P goes in the middle. We're going to have less than or equal to on either side. Let's see, P must be less than or equal to 20, that's the upper bound. P must be greater than or equal to 20, that's the lower bound. And then our graph, I think I can fit it right here. We have 50, 200, close circle, in between. So there you go. Okay, so those are the word problems. And I think on your homework you have, well, I know you have one, you might have two, so hopefully you took good notes here. Alright, now let's talk about special cases. Okay, now remember, absolute value represents distance. Distance cannot be less than 0. So remember what happened is we had situations that were all real numbers or no solutions. Those can happen with absolute value inequalities. Alright, so here we go. In this problem here, I'm going to minus 7 because I want to isolate this. So now I get the absolute value of x minus 3 greater than negative 5. Now, listen very carefully. Whenever you're solving an absolute value inequality, and when you go to isolate your absolute value, if you end up with a negative over here, notice I haven't split it up yet. Okay? Then you need to stop because it means it's a special case. Notice on all the problems we've done, we've always had a positive number over here. You see that? Even here. See how it was positive? So we split it up and we got two answers. When we moved that 7, it gave us a negative answer over here. Means my answer is special case. So now let's think. This says the absolute value of x minus 6 greater than negative 5. In other words, an absolute value greater than a negative number. Well, what kind of numbers do absolute values give us? They always give us positive numbers, right? So this is really saying positive numbers greater than negative numbers. Well, aren't positive numbers always greater than negative numbers? Yeah. So in this case, the answer is all real solutions because it's true. Positives, this will always give you a positive answer right here. No matter what you put in for x, you will always get a positive answer out. And it'll always be true. Let's check. Let's say I want x equal to 2. So I would go 2 minus 6. I would get negative 4. But absolute value of negative 4 is positive 4. There you go. You can pick anything you want. It'll work. Okay. Alright, let's do the second one. Okay. So over here we're going to add the 5. And we get -1. So we get absolute value of x plus 12 less than or equal to -1. Now remember what I said. If you get a negative over here when you're trying to isolate the absolute value, stop. It's a special case. So what is this telling us? This says the absolute value of something is less than a negative number. But an absolute value will always give us a positive number. So let's ask ourselves, can a positive number ever be less than or equal to a negative number? No. So our answer here is no solutions. Nothing works here. And then just to do a quick check, let's do x equals 2 again because it's a nice small number. So here I get the absolute value of 14. So 14 minus 5, that's 9. Is 9 less than or equal to -6? No. Okay? So, whenever you're solving your absolute value inequality, if you get a negative number over on the other side before you've split it up, it's a special case. Alrighty. Now it's your turn. Go ahead and do both. So pause the video. Alright, now that you've had a chance, let me do them. Let's see how you did. Okay, it's negative, so basically this says a positive number greater than or equal to a negative number. That is always true. Over here, I would divide by that 4. Negative. So this says positive number less than or equal to negative number. Whoops. That is never true. Okay? So that's it for the special cases and word problems. Hopefully it makes sense. Just make sure you take your time on your homework. And that's it for this video.